we have seen the different kinds of decimal numbers. They are broadly classified into terminating decimals and non-terminating decimals. Terminating decimals are the ones that do not go on forever. And non-terminating decimals, as the word suggests, are decimal numbers that do not end or do not terminate. Non-terminating decimal numbers are classified into two types: recurring and non-recurring. The non-terminating decimals are called recurring if there is a set of digits after the decimal point that repeats forever. And they are called non-recurring if there are no sets of digits after a decimal point that repeat forever. In this video, we will be looking at this category: non-terminating recurring decimals. We can also call them recurring decimal numbers. We will look at 5 very simple examples: 0.66666 and so on. You would have observed that you spent a lot of time writing it. You're not even sure about how many sixes you need to put after the decimal point. In such cases, we use a very simple notation. We write it as 0.6 with a bar over the number 6. These two are equivalent. We just put a bar over the number that is repeated. We may even put a dot over the number that is repeated like this. So all these three values are the same, but writing it in one of these ways is a lot simpler and definitely cleaner. Here's a second example: 2.777777 and so on. In this number, the part 7 is repeated indefinitely. So we can write it as 2.7 with a bar over 7. We can also write it as 2.7 with a dot over 7. Very simple, right? Okay, let's look at an interesting example now. 18.525252 and so on. Focus on what's repeated. Here, the part 52 is repeated indefinitely. So we can write it as 18.52 with a bar over 52. We can also put a dot, right? So after we write 18.52, where do we put a dot? Over 5 or over 2 or between? Actually, neither. We put a dot over 5 and also over 2. So this tells us that 52 is repeated. Now it's getting a bit more interesting. Let me make it slightly more difficult. The number is 5.65327, 65327 and so on. In this example, 65327 is repeated. So we can write it as 5.65327 with a bar over 65327. That was simple. But how do we put dots over the repeating part? 5.65327. Where do I put the dots now? On all the 5 digits to show that they're all repeated? We do not do that. Instead, we put dots over the first and the last digit of the repeating part. So we put dots over 6 and 7. This tells us that this entire part is repeated. Here's our last example: 7.15232323 and so on. Here, the initial 2 digits after the decimal point are not repeated, but 23 is repeated after that. So what do we do about this part? Simple. We don't put a bar or a dot over it. We just ignore it and write it as is. It can be written as 7.1523 with a bar over 23, since that's the only part which is repeated. And how can we write it in the dot format? We write 7.1523 with dots over 2 and 3. That's all you had to know about representation of recurring decimal numbers. The first 4 examples we saw are pure recurring decimal numbers. We call it pure since all the numbers after the decimal point follow a repeating pattern. Now look at the 5th example. The first 2 digits are not part of the repeating pattern. 15 is not repeated. So what do we call this kind of recurring decimal number? No, we don't call it impure. We call it a mixed recurring decimal number. It's a mixture of non-repeating and repeating.